hello. This is Professor. Will it go boom? Welcome back. Welcome to the neighborhood. So glad you could come again. You're here to do some science, perhaps? Good, good, good. Today we'll turn some attention to the kitchen. Yes, the kitchen. We've talked before, let's see, we've talked about many things, but I think recently we talked about blood. Talked about the blood. And then after that, I think we talked about the methods of heat transfer. And one of my favorite places to see heat being transferred is in the oven. I like to see it being transferred from the heating elements, whether it's the electric heating element or the burners, the flames, getting it up into the pie, the hot apple pie. Or perhaps if you've been a very good boy, very good girl, if you've been very good boy, very good girl, perhaps you get cabbage pie. Oh, cabbage pie. I can just smell it now. And I'll probably be able to smell it later too. Perhaps. So let's turn our attention to the humble cabbage. Basically, it is a vegetable, and I have read that it is red, but to me, it looks more purple. But we call it the red cabbage. Red cabbage. Chinese cabbage, I think perhaps it's also called, but not radicchio. Don't be ridiculous. Ridiculous. Don't be that. Okay, so the cabbage, the red cabbage, right? Good in the pie, the cabbage pie, very good. Good in the kraut. Good, sauerkraut, or not, depending Bavarian style with the seeds. But but the cabbage is red, right? So something interesting we can do. If now this is the part where you have to get the parents' permissions. Okay, it's a list. Okay, so let's remember there's some things you have to have the parents' permission before we can start to do the experimentation, right? And you have to have some help getting the ingredients. There's various things that you can use. Most of the time, you can do substitutions, but for this one, if you can get the red cabbage, that's gonna be what you want to find, okay? Red cabbage, I don't think you can do this with the green cabbage because it doesn't have what's that word? It's the anthocyanin, yes, anthocyanin. And it's in the red cabbage. So before we get the cabbage, we get the parents' permission because you'll need to find this. You can find this in the lettuce mixes sometimes, the little red squiggles are these. So if you have bags of the ready-made salad to go, and you get out the little red strips and you connect enough of them, or you order one, then you can create your own at home with the parents' permission. Okay, so we'll show the processing later. But for now, you can do that at home. And speaking of home, we must talk about the parents' permission and then the safety, right? So Forky does safety. See, he has the safety goggles, the goggles for the safety of the eyes. And so the Forky does safety first, right? Safety first. So remember, Forky does safety and you do safety at home. I have on the goggles because there's liquids and we could get the splashing, right? So it's Professor, will it go boom? Most likely not, perhaps, but will it go splat? Yes. It always goes splat. Earlier, before we got setting it up, we had the splatter, right? To clean up the splatter. What's the matter? Matters the splatter. That matters. Okay, so you'll get the parents' permission, you have the safety equipment, and then you have to do the processing, right? So this is another part where you need the parents' help, okay? Because it involves, hi, peekaboo, it involves a knife, right? So first we would quarter, so we would take this, and this, I'm telling you this because it's a safety, and you want to do it the correct way. You want to get the flat side and put it down, and the parent will cut it in half once, and then lay those halves in half, and half to half, and half to half, but always a flat side down so it doesn't roll out. It's very hard to cut cabbage, so make sure you have the parents' help. In fact, it may be easier for you to do it with a grater, and just grate it off like it's cheese grater, okay? That's great, you do that with a grater, that's safe. Better, but watch out for the knuckles. Don't grate the knuckles because then it's really, really red cabbage. And going back 2 lessons or so ago, you find out what type of blood you have. Don't do that with the grater, okay? Good, safety. So we quarter it, okay? And then we chop it into smaller pieces that fit into a blender, okay? So you see the chunks, make it into chunks. Little bit of water helps, okay? And then we chop it up, we add those ingredients, chopped ingredients to the blender, and we puree it into a mush. Very scientific term, it's a mush. And the mush has a lot of liquid in it until you put it through it's like a filtration, right? So the first filtration is just a simple strainer. And it's less, so you see the liquid goes right through. Pretty good. And then you take the liquid, okay, and you run the liquid through this filter, and you could see And actually, you could do this if you want to save a step. You can do the double filtration. You have the big one to catch the big chunks, and then you have the little one to catch the little slivers, and then the liquids go through. Obviously, I didn't start with a clean container because I didn't want to waste a lot of water cleaning this one when I'm still experimenting. But you would have a clean container with the coffee filter on the strainer, right? And then you would just pour it through, and you can see what comes out when it starts to come out. And you can actually press this lightly to help it out. What comes out is just liquid, okay? There's no pulp, pulp. It's hard to say that word, the pulp, but it has no pulp. So we start with the big cabbage, we quarter it, we have it, we slice it, we slice it, we turn it into the puree. And I got to tell you, it doesn't look like much, but it's not the worst thing. No, wait, that's not cabbage. That's a V8. This is the cabbage. Cabbage water. Very healthy, very healthy. Makes you feel alive. Good. Okay, so now we've gone through all these processes, and now we have this, okay? This liquid, which is going to do wonderful, magical things for us. This liquid will act as a reagent and an indicator, okay? It will be a coloration which will demonstrate the properties of the things we're going to test. So let's say that my assistants here, okay, whom I don't think we have named. I probably need naming suggestions from you, my viewers, my friends, my comrades, my fellow experimenters and scientists. I need some recommendations for my friends' names. Right now they are just, assistant A and assistant B. So I need A assistant. Can you be there, right? So it is that? Okay, good. So my lab assistants, they were saying to me the other day, they were saying, Dr. Villigo Boom, professor, can you tell me, am I a base or an acid? And I said, I don't know. And I said, why? And they said, well, we want to go on this new app where you make friends, and it's like a basic chemistry meet and greet kind of a place. So they want to know your chemical properties. And so just like when we had our blood types, right? We had positive and negative, right? We had the RH factor. We had those things, so your characteristics define who you are in certain aspects of expressing who you are. So they wanted to know more about themselves, and I said, well, it's been a while since I made you guys. I don't remember if you're acids or bases, but we can find this out. And so then we got into sort of saying, well, what is an acid and a base? And I said, well, let's not get ahead of ourselves. Let's start with water. Okay, water is kind of the middle of this whole thing. So let's start with the water. The water, when we start out, was going to have this kind of purple color. And that's representative of its pH, okay? So the acids and the bases, they live on the opposite ends of this scale, this pH scale, okay? And it goes from acid with a number of 1, all the way to number 7, where we get into water is neutral, so it's not an acid or a base. It can be acidic or basic, but in and of itself, just the molecule of water is not. It's neutral. Okay, it's a nice 7. On Z, if you go higher on the pH scale, you get into the bases. Okay, so you might ask me, what's this math? This acid, this base. What does this tell me? What does this do? So if you're trying to accomplish certain tasks or to create certain reactions, you need an acid or a base because it has different effects on things. So if you want to remove corrosion from metal, like if you had a penny and you want to make it shiny, you could put it into an acid or a very strong base, and it would dissolve away the oxides that form on top of the metal. So you can use it for cleaning, right? In fact, many household cleaners, which are, drain cleaner and the rust and scale removers, these things rely on these properties of being acids or bases to do this work. So it's very important stuff. So I'm seeing we're going to be very long today. This is probably going to be a part 2, okay, a part 2. But as acids and the bases, they get into this whole properties, and so we start with the humble water, okay, and we take the acids and base, and what we do is we just say, I don't really think that I like this water thing. I'm gonna break this up and see what I can make with it, So here it turns out I can make with the water, I can make, and I always get confused. Let me check my notes here. So I can make a cation, which is the positives, the hydrogen from the, I forget these things. So forgive me, we're not doing basic chemistry, but we are, so we must at least acknowledge these facts. So I said that this was the water, okay? So I don't know if it's upside down, right side up, because the O's and the H's, they're invertible, but, so if we say that this is the water molecule, right? And it has the hydrogen molecules, which is times 2, is the H2O, is two H's, right? H and H, H2O, oxygen. So hydrogen and oxygen and hydrogen, this H2O is the arrangement of the molecule that makes up the water. So conveniently, when you break it apart, you make two building blocks for many chemistry things. You have the cation, the positive hydrogen, okay, because it is looking for an extra electron. And then you have the anion, which is the oxygen and the hydrogen. So the hydrogen and the oxygen, they are sharing, okay, so you're sharing an electron, but you have this empty spot over here. So what does this empty spot look for? It looks for a friend. Oh, hey, I found a friend. Click. And now when we combine, we make the water. Okay, so we can say that by splitting water apart, right, we can make these two things, the cation and the anion, and with these we can get, depending on how many are split off, we can get a very strong acid, in the case of if you have lots of extra of these that have been split off and put into the liquid, or you could have lots of anions and you could be very basic. Okay, so for the demonstration today, look, red is representing our acids today, and blue is representing our bases. So now we have these household chemicals. And later, in another episode, I will tell you how it is that you can tell the difference between whether they're acids or bases using the red cabbage. So red cabbage will be useful in our next experiment. Stay tuned. See you again. Same Will It Go Boom time, same Will It Go Boom channel.